Hello, students. This video will give the guidance of how to apply our solubility rules to judge if ionic compounds are soluble or not in water. If you find in your unit packet, page 4, there I have 2 tables. You will not have to memorize this information. Again, you will not have to memorize this information. I will provide this same set of tables. It's choosing the one that just makes more sense to you to apply. This bottom table is actually from your textbook, and it communicates exactly what this table does, but in sentence form. These tables do not contradict. They agree with each other. My analytical chemistry brain just appreciates and understands this one better. So I'll guide us using this one if you don't mind. All right. What we need to be able to do is, if given a set of formulas, can we judge using the table if they will be soluble or insoluble? So again, this table only addresses the solubility of ionic compounds in the solvent of water. If our compound, so let's say it's A2B, just being so generic. If it is soluble, we know it dissociates. And if it dissociates and is soluble in water, then I would use the phase symbol of AQ. Let's say that there's another compound, let's just say it's XY, and we find it is insoluble, and it will not dissociate. So we would write S. It is not soluble, no dissociation, will not act as an electron. All right, so how do we apply this? Well, I would look at the formula and break up the cation and anion in my mind, and then see, do the cation or anion fall in this soluble portion? So here, these are primarily soluble as long as whatever these are bonded with are not an exception. If it is an exception, then it makes it insoluble. And we'll go through examples. If the cation or anion are part of this part of the table, well, then they're insoluble, but we need to check the exceptions. The exceptions, if these are bonded, would make it soluble. Let's apply the table. So if I were to read this formula, I would look at, okay, sodium and sulfate. Sodium. Well, alt is the first thing I see. Sodium, whenever it's in a compound, so look, there's no exceptions. No matter what, whatever it's bonded to, it will be soluble. And so it will dissociate. I would write it as separate ions if I needed to do that, but it's soluble. I'll put an AQ on it. All right. How about aluminum hydroxide? Well, this is aluminum and then hydroxide. Well, do I see aluminum? No, but I see hydroxide. Hydroxides are usually insoluble. Is aluminum an exception that would make it soluble? No. So this gets solid phase symbol. It is insoluble. All right, let's go to magnesium acetate. So I'll check magnesium +2. Nope. Acetate. Oh, yeah. No exception. So soluble would get an AQ. How about silver bromide? Well, silver, no. Here are my halides. I know fluoride is not included here. We would go ahead and include. So if anything is bonded with chloride, bromide, iodide, fluoride, usually soluble, we need to check. Oh, if it's bonded to silver, that makes it insoluble. And we would put the S on it, not AQ, if we were asked to do that. So we just need to practice, and something that we'll do in class and on homework is definitely apply this, not to be memorized, just to be interpreted.